The idea was simple. I would 3D print a rocket engine and protect its walls using vortex cooling. This worked pretty well with air and propane, but once I added oxygen, it became really unstable and hard to control. To make my life easier, I decided to 3D print the entire engine in ceramic resin that can withstand up to 1500 degrees Celsius. But easy was not on the menu. It's not easy to 3D print ceramic parts, and I quickly discovered that they leak. This video was brought to you by KiwiCo.
Okay, so I just 3D printed the three main parts that make up the rocket, and because I know you guys are a little bit tired of watching me remove support material from the parts, I'm gonna use some editing magic this time. What? I'm not Zach King. Anyway, I removed the support material from the parts, and now I need to find a way to seal them. You know, so the engine doesn't leak again. I'm gonna use your ideas. You suggested a ton of them, but I think there's two that are really cool and promising. The first one is glazing the parts, which is the traditional process to seal ceramic parts. But there's a little problem with that idea. Glaze is basically a thin sheet of glass around the part, and glass shatters. So instead of glaze, I'm gonna use a ceramic slip. The second idea is really cool. It's electroplating the parts, which is a very cool process in which you add a thin sheet of metal around the part using electric current. I always wanted to use this process, but I never really had a practical excuse. Now I have.
I started off by trying the ceramic slip idea. Slip is basically a very fine ceramic powder that is used in pottery to cast ceramic parts. I mixed it with water and I dipped the parts for about 10 seconds. In the first inspection you can see that a thin layer of slip was formed around the parts, which is promising. I used my kiln to cook the parts for about 7 hours to sinter the slip and make it temperature resistant.
Okay, so the parts are finished sintering, and just by touching the parts I can tell they are more dense. Like, I can't see any cracks or pores, so that's nice. But anyway, the only way for me to know for sure is to assemble the engine and test it. So let's do that.
On my other videos I fixed the rocket engines in my vise, but that doesn't really give me much information about their performance.
A cool thing to do would be to put the rocket on a rail, like a linear guide. So if there's any kind of thrust, well, the rocket will be pushed forward. The problem is that for me to order a linear guide right now, it would take me at least a week to get here. So instead I decided to use my... Just a second. My 3D printer. It has a linear guide on it. High quality, actually. I'll put it back together again. Don't worry.
A few moments later.
Look at that. So smooth. No friction.
After getting the spoils from the dead carcass of my 3D printer, I 3D printed some limiters in red PLA so the rocket doesn't shoot out and starts flying around my shop. I assembled the engine and gave it a go.
Clicking. Where exactly, I don't know.
Well, let's check the slow motion footage then. The engine seems to be leaking primarily through the nozzle, but once I increase the chamber pressure, it starts leaking through other places. It's definitely not leaking as much as the other engines, and that means the slip dip actually helped. The engine didn't really move though, so I gave it another go, this time full throttle. Okay, so I burned the hole in my table, but the engine moved, which is pretty awesome. If I play my cards well, I might just get a fully working rocket engine.
So I decided to go all in, and what I mean by that is, why not slip dip the parts and then electroplate them? That should give me the best result, right?
So I 3D printed two vortex engines and I dipped all the parts in ceramic slip. While they were on the kiln getting sintered, I moved on to the electroplating part of affairs.
Electroplating is a very interesting process in which you deposit metallic ions onto a part's surface. To do that, you need electrical current, a solution with metal ions, and of course a part with a conductive surface. And right here you see where things go south for me, because if there's one thing that my ceramic parts aren't, is electrically conductive. But as always, there's a way to fix that.
Graphite, It's the crystalline form of the element carbon, and because of that, if you heat it and compress it enough, it becomes a diamond. It's also a very good lubricant, it's used in pencils, it's resistant to high temperatures, and it's an excellent electrical conductor.
And because of that, I'm gonna use it to try and make conductive paint. Yep.
And try I did. I mixed some graphite powder with acrylic paint and I used water to thin it out. I tried some different proportions of the aforementioned ingredients and settled on a paint that was easy to apply and also had a low resistance. I painted some ceramic parts so I could later cover them in metal.
In this case, the metal I chose was nickel, because it's supposedly easy to plate, has a silvery finished look, and can withstand up to 1500 degrees Celsius. I got myself some nickel strips to use in the process, but I still needed a liquid full of nickel ions. And to get such a liquid, which bears the name of Electrolyte, I got myself some white vinegar. I say that word slowly because I have an accent, and that's a tricky word.
White vinegar, which is basically acetic acid, and what I did with it was pour it into a flask. Then I added a little bit of salt to increase the electrical conductivity of the solution, so the ions can flow freely and without restraint in the white vinegar. After that I added 2 strips of nickel on each side of the flask and forced some electrical current through the solution. This starts a reaction called electrolysis that releases hydrogen in the gaseous form and also produces nickel ions. After some hours I should get a concentrated solution filled with nickel ions, which should have a clear green color, like this. But that was not what I got.
So I failed miserably trying to create a nickel acetate, which would be the electrolyte to perform nickel electroplating. I don't know exactly why. It's supposed to be like a clear green color, but it's not. It's just this looks like sewer water. So I don't know what's going wrong. I'm gonna try something easier, copper plating, because I can use copper sulfate, which I don't need to create, I can just buy, and I'll try it that way. I will not have that silver finished look, but it's still metal, it should work, its melting point is a little bit lower, but yeah, let's try that.
Sponsor time! Kids! They are very innocent, cute, and energetic, but also very stupid. Don't trust me?
Go away.
Sorry, Luana.
As intellectually superior beings, it's our job to jam important information into their tiny heads, like for example the Pythagoras theorem, the laws of physics, and of course the fact that tomatoes are disgusting. To help us in this mission, we can use the educational tools provided by this video's sponsor, Kiwico. Kiwico creates super cool hands-on projects that expose kids to science, technology, engineering, art, and math. STEAM! Every crate comes with everything you need, so your kid can focus on the project and not turning off my printer that was printing for 10 hours straight. Right, Luana?
Guilty.
Kiwico believes that small lessons today can mean big world-changing ideas tomorrow. And let's face it, it's time someone invents the warp drive and the teleporting machine. The problem is that someone is probably a kid right now, so let's give him a little nudge. To support the invention of the warp drive, you can get your kid some crates using the link www.kiwico.com/integza50 that is in the description down below. If you use my link in the description down below, you will get 50% discount on your first month, and also you're supporting my channel. And to that I say, arigato. Back to the video.
So I bought some copper sulfate that has a beautiful blue color that reminds me of Alexandre Daddario's eyes. Look at that, so hypnotizing. I would eat a tomato if she asked me to. I mean it. Anyway, I poured some Alexandre Daddario into a flask and I mixed it with water until I got a very concentrated solution. The water needs to be distilled so you don't contaminate the Daddario sulfate. I placed a chunk of copper on one side to be connected to the positive pole of the power supply, and I used some chopsticks to dangle my parts in the Daddario sulfate. I did a test with a screw and that didn't work, so I tried a washer, and that didn't work as well. The copper was all coming out. I did some research and I found out that it's really hard to copper plate steel, so I gave a try to the part that I painted with my homemade graphite paint, and guess what? It didn't work as well. I ended up trying the only other metal I had home, the nickel strips, and that worked. The copper bonded pretty well and was not coming off.
Okay, so I can plate nickel strips with copper. So what? That doesn't really help me. I want to plate my parts, and the graphite paint was a dead end.
In Texas, it baffles me how many people subscribe to your channel. You are one of the worst engineers I ever had the displeasure of meeting.
Oh yeah? You're not even the worst tomato I ever met. Your father was much worse.
Oh, my feelings. I could almost cry. You're only saying that because my moronic father would accidentally make people like your videos and subscribe to your channel. Even worse, it would give you epiphanies that would solve your problems. You're not getting that with me on the picture. With me, there's no silver lining for you.
Yeah, no ideas. You're just annoying.
Actually, silver lining is a horrible analogy for a happy ending. I used to have a silver crown, and what I got were silver lightnings in my head.
Oh yeah, that's because silver is the most conductive metal on Earth. Oh shit, that's it!
Oh, so these were the moments my father used to complain about. I miss Papa.
So, I found this silver paint on the internet that actually contains real silver on it. I painted a ceramic aerospike nozzle I had laying around with the most expensive paint I ever bought and dipped it in the Dario sauce. And it worked! The copper was sticking itself to the surface of the part. It's just weird. Science sometimes looks like witchcraft. I painted all the parts with the magic paint that I had to sell my car to buy, and I plated the crap out of them. When I said I painted them, I mean my sister Katerina painted the parts. I'm not good with crafts.
Another one is finished. My sister is watching Gilmore Girls. It's kind of an okay show. Well, now she's not watching. She just got very timid. Yeah, this part is done. Nothing on.
Look at it. So pretty. Oh, the nozzle now.
Once I was finished plating the parts, I filled some potential leaking spots with refractory glue and I assembled the engines.
Okay, so me and Katrina are about to test the engines, and in the name of safety I bought these. These are flashback arrestor valves that don't allow the combustion to go back to the tank and explode my house. This was actually a suggestion from someone in my Discord. His name should be appearing here. On this topic I also bought this. This is, well, everyone knows what this is, and everyone knows why I bought it. It's pretty obvious, I'm testing rockets on my attic. But also because, well, spring just arrived, and with spring come flowers, and with flowers come bees, and my attic is full of them. They have been attacking me and Katrina since we started building the rockets, so if they decide to make an appearance while we're testing them, well, you know. I don't know. Yeah, this is the monstrosity that I built on the last video. I just want to test the thrust. Let's do that.
Okay, we are ready.
We are ready?
Yes.
Okay, let's do this. Ignition! Okay, I think we can test it again, even though it's all mushy. Yeah!
Are we recording?
Yes.
Are we?
Yes.
Okay, this is the first test with the rose and gold rockets. Yeah, Elon Musk, do you have rose and gold rockets? Don't think so. Okay, ignition. Wow. We blew up the rocket. That was loud.
Yeah! Zero leaks! No leaks! I love it! It's the liquid! It's the copper sulfate! It's totally working!
We need to do it again.
Why? Not again!
Okay, so I blew up, I think, 2 or 3 engines, and I 3D printed the back lid again, and basically I'm reusing this engine to see if everything goes right this time. I think I know which is the problem. I think it's the ignition, because the spark plug is very tangential on the engine. I don't think the mixture of oxygen and propane is getting to it. So when it finally gets to it, there's a big accumulation of basically propellant on the combustion chamber, and detonation occurs. So if that's the problem, I solved it, because I'm using 2 copper nails that goes right straight into the center of the combustion chamber. That should solve the problem. Let's try it. Be careful now, Katrina. And it's gone. So close. But yeah, I think I'm right. I think it's the ignition. Did you see that? Completely blew off the lid. What a power. Okay, let's try the other one. The ignition is still working.
Tá na câmera.
There's a bee on the camera. Where? Oh shit! Where's the fire extinguisher? Away!
The moment.
Okay, do you have the fire extinguisher? The bee is there. Can you see it? Look at her. Look at her. Katrina, hit it! Yeah! For the rescue. Oh, Jesus Christ. We just frozen our ceiling. And it's gone.
Okay, so I blew a lot of rockets and I didn't really win the war on the wasps. But one of the rockets worked pretty well, and the wasps weren't really able to sting neither me or Katarina, which I guess it's a one battle. Anyway, I think I can finally say that I built a working electroplated, 3D printed, liquid-fueled, vortex-cooled ceramic rocket engine. Whew, Jesus, I can't believe I said all of that in one breath. I'm still not satisfied though, because I really want a rocket that produces thrust and doesn't blow up 4 out of 5 times I make it run. Well, I have built solid rocket engines and liquid-fueled rocket engines, so maybe it's time I tackle the in-between. What do you guys think? I'm well aware that not everyone watching my videos has a 3D printer at home to replicate these projects, And that's the reason why on my last video, I gave away a 3D printer to the most liked comment suggesting a theme for a future video. The winner was Stefan Lazig, and he suggested that I could build either a pottery wheel or a CNC machine. I don't think I see the overall idea there. If you also want to win a 3D printer, all you need to do is subscribe to the channel, leave a like on this video, and post a comment suggesting a theme for a future video. The most liked comment will receive a brand new 3D printer. Well, I guess this is everything for today. Thank you so much for watching, and remember... Wait, which printer is that? Don't forget, tomatoes are disgusting.